Hello everyone, and welcome back to our channel. Today, we're diving into the fascinating world of finite element analysis, or FEA. This powerful tool is a game changer in engineering and design, giving us the ability to simulate, analyze, and predict the behavior of products under various conditions. Our main goal today is to provide you with the best tips for improving design accuracy using FEA. So, without further ado, we're jumping right into our first tip. The first step is to fully understand your design intent. It's all about knowing what you want to achieve with your simulation. Are you looking at stress distribution, thermal behavior, or fluid dynamics? Identifying these key factors will guide you in defining accurate boundary conditions, loads, and constraints. It's like having a roadmap for your journey into the realm of finite element analysis. Once you've understood your design intent, the next step is to choose the right element type. Choosing the right element type is crucial. In finite element analysis, you'll encounter a variety of elements: beams, shells, solids, and even more complex types. The one you choose can greatly impact the accuracy of your results. Therefore, it's essential to consider factors such as the geometry of your design, the behavior of the material involved, and the loading conditions it's likely to experience. By carefully selecting the appropriate element, you ensure a more accurate and reliable analysis. With the right element type, you're ready for the next step: meshing. When it comes to FEA, proper meshing is a game changer. Meshing is the process of dividing your model into smaller elements, each acting as an individual player in the grand scheme of your design. This process directly impacts the accuracy of your simulation results. However, keep in mind, a fine mesh captures detailed behavior, but can be computationally heavy. Striking a balance is key. Use local refinement where necessary, especially around stress concentration areas. With a well-meshed model, we can now focus on material properties and boundary conditions. Accurate material properties and carefully applied boundary conditions are integral to realistic simulations. Material properties like elasticity, plasticity, and others, when correctly inputted, provide a reliable foundation for your analysis. Boundary conditions, including supports, loads, and restraints, serve to mirror the conditions of the real world within your simulation. It's not about merely setting these parameters, but understanding their impact and adjusting them for optimal results. Once you've set these, it's time to run a convergence and sensitivity analysis. Running a convergence analysis and sensitivity analysis can greatly enhance the accuracy of your simulation. Convergence analysis is about ensuring that your results stabilize as the simulation progresses, while sensitivity analysis helps you understand the impact of changes to your parameters. Both practices are critical in achieving accurate results. Convergence confirms the stability of your solution, and sensitivity analysis shows how susceptible your results are to changes in inputs. With the analysis complete, it's time to validate and verify your results. Always validate and verify your simulation results against physical tests or established benchmarks. This is a critical step in the finite element analysis process. By comparing your simulation outcomes with real-world data or trusted standards, you ensure the accuracy of your predictions. This isn't just a box-ticking exercise, it's a crucial reality check that your model is behaving as it should. Remember, the goal is to mirror real-world behavior as closely as possible. After validation, the final step is interpretation and iteration. Interpreting FEA results requires engineering judgment. It's not about blindly accepting numbers, but understanding why things behave as they do. If your results differ significantly from expectations, don't be disheartened. This is where the power of iteration comes in. Adjust your inputs, refine your mesh, or tweak your boundary conditions, and rerun the simulation. Every iteration brings you closer to accuracy, enhancing your understanding of the design. And that wraps up our top tips for using FEA to improve design accuracy. Remember, mastering FEA takes time and practice, so keep iterating and learning.